Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 9th, 2025, just about a week ago. This paper introduces a framework for building a state-of-the-art image captioner, comparable to models like GPT-4o, for less than $1,000. The paper is titled Vision Language Vision Auto-Encoder, Scalable Knowledge Distillation from Diffusion Models, and the implications for making powerful AI more accessible are pretty significant. It achieves this by distilling knowledge from diffusion models using mostly single-modal images, avoiding expensive paired datasets. Also, the authors shared their implementation on GitHub. If you check it out, you'll find everything you need to get started, including the training and inference scripts for both captioning and image reconstruction. They've also included instructions for dataset prep and links to the pre-trained checkpoints. And on Hugging Face, the 3 billion parameter captioner model is available to download, complete with code examples, so you can start generating your own captions. Alright, so the first figure really hammers home these claims. On one side, you see a cartoon image, and the caption from the new Vision Language Vision Model, or VLV, is incredibly detailed and accurate, right on par with GPT-4o. Then, the charts on the right compare performance and cost. Their quality scores, measured by Fréchet inception distance, which basically tells you how well a caption represents an image, are nearly identical. But the training cost is astonishing, under $1,000 for VLV compared to an estimated 100 million plus. And the efficiency for generating new captions is just off the charts. So how exactly do they achieve this? Well, this diagram lays out their clever two-stage process. In the first stage, called Vision Language Vision Auto-Encoding, an image is fed into an encoder. The goal is to compress that image into a compact numerical representation, a set of caption embeddings. Then, a frozen diffusion decoder, which is a powerful pre-trained image generator, tries to reconstruct the original picture using only those embeddings. This process forces the embeddings to capture all the essential visual details. In the second stage, those same rich embeddings are instead sent to a caption decoder, which is an LLM trained to translate them into a detailed text description. And this next figure gives a fantastic visual breakdown of those two stages in action. The top row shows the original images. The middle row, that's the output from stage 1. It shows the reconstructed images created by the frozen diffusion decoder, using only those learned caption embeddings. You can see they preserve the high-level concepts and even fine details really well. Then, the bottom row shows the result of stage 2, where those same embeddings are turned into a text caption, and then that caption is fed to Midjourney to generate a new image. The fidelity is just remarkable. This table then provides the hard numbers to back up those visual results. What we're looking at here are Fréchet inception distance scores. And remember, a lower score means a better, more accurate caption. The columns show different guidance scales, which is basically a setting that controls how strictly the image generator follows the text. And as you can see, the Vision Language Vision model consistently achieves very low scores, outperforming other open source models. It's right in the same league as the big proprietary models like Gemini 2.0 Flash and GPT-4o. Okay, and it's not just automated metrics that tell this story. This next table shows ratings from both human users and another advanced model, Gemini 2.0, judging the quality of the captions. On a scale of 1 to 6, you can see the average scores. The Vision Language Vision model scores a 5.18, which is practically identical to GPT-4o's score of 5.23. This result really drives home the point that their model produces captions that are, for all intents and purposes, just as good as the top proprietary systems. Building on those impressive quality ratings, this next table explores how well the model scales. The two charts here show Fréchet inception distance scores, and remember, lower is better, as two key variables are changed. On the left, you can see that as the number of training images increases from 6 million to 40 million, the scores consistently drop. And on the right, we see a similar trend when using a larger caption decoder, which is the LLM part that writes the final text. This demonstrates that the Vision Language Vision approach is robust and predictably improves with more data and bigger components. So to wrap things up, the big takeaway here is really twofold. First, the Vision Language Vision Framework proves you can get state-of-the-art image captioning, on par with models like GPT-4o for a tiny fraction of the usual cost, under $1,000. And second, the key is their clever use of knowledge distillation. That's a process where a model learns by distilling information from a powerful pre-trained system. Here it uses a diffusion model to learn rich visual details from images alone, which is a really elegant and efficient approach. That's all for today. Thanks for tuning in to the AI Research Roundup. I'm your host, Alex.